Welcome to a new video by Wiskunne English. This video is the second part of finding the domain of a function without knowing the graph of the function. So in this video, I promised we're going to make exercises on ln and logarithms. So we know that if you take the log of x, that x must be positive and not equal to 0. Now, suppose we have y is equal to the log of x minus 1 divided by x plus 1. The first problem I see is that we have a fraction in the logarithm. And we know from the last video, if you have a fraction, that if the denominator is 0, that we need to exclude that point from the domain. So we have x plus 1 is equal to 0, or x is equal to minus 1. So we already know that we need to exclude minus 1 from the domain. Now we need to find out where x minus 1 divided by x plus 1 is positive. So we're going to use a sign diagram. For a sign diagram, we need zeros. So we are going to find out the 0 of the numerator. Because we already have the 0 of the denominator. So we're going to find out the 0 of the numerator. So x minus 1 is equal to 0, or x is equal to 1. So now we have everything we need for the sign diagram. So we write x minus 1, 1. We can split it up, so we can use numerator, denominator, and let's say the function, so y. So we know x minus 1 is equal to 0. It's a straight line, it's positive, so minus, 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 plus. X plus 1 is a straight line, also positive. 0, minus, plus, plus, plus. If you look at the function, this is in the denominator, so this becomes a vertical line. Minus, minus becomes plus. Minus, plus becomes minus. 0 plus becomes 0. Plus, plus becomes plus. Now, we know x minus 1 divided by x plus 1 must be larger or equal than 0. So we have minus infinity to minus 1 with both brackets to the outside. Here because it's minus infinity, here because it's a 0 in the denominator. And 1 plus infinity. Why? To the outside, because 1 gives 0 and the log of 0 does not exist. So this is the solution for a domain. This is just end. So this and this. So you see we had a fraction in the logarithm. So fraction in the logarithm means denominator exclude the point that the denominator is 0. Then sign diagram, and we find the points where the domain over x exists. So the domain. Second example. Suppose we have the logarithm of the square root of 2x. Now, here the logarithm doesn't matter, because the square root is always positive. The only thing that matters is square root may be equal to 0, but the logarithm can be equal to 0. We cannot take the logarithm of 0. So we know 2x must be greater than 0. The square root tells us it must be greater than or equal to 0, but the logarithm says that this may not be equal to 0, so it becomes greater than. So x must be greater than 0. So an easy solution, it's 0 plus infinity. So this exercise looks difficult, but it's quite easy. Now the third exercise is the most difficult one. Suppose we have the logarithm of the logarithm of the logarithm. I'll use square brackets of x. Like this. Now, how we are going to solve this? Because we know that the logarithm, this must be positive, but then this must be positive, and we're a bit stuck. So, what are we going to say? We say that the logarithm of the logarithm of x is equal to b, for instance, and that the logarithm of x is equal to a. So first step, we have the logarithm of b. And we know that b must be greater than 0. So we know that b is greater than 0. So, because the logarithm, always, this must be greater than 0. So b is greater than 0. Next step, we have the logarithm of x is equal to b. But the logarithm of x is equal to a. So we have logarithm of a is equal to b. Because I substitute this one by a. And we know that we can write 10 to the power of b is equal to a. Now I know that b is larger than 0. So this is larger than 1. So a is larger than 1. Because if b is smaller than 0, it becomes smaller than 1. So if b is 0, it's 1. Larger than 0, a is larger than 1. Now I know that the logarithm of x is equal to a. So write it here. So we have a nice summary. Logarithm of x is equal to a of 10 to the power of a is equal to x. Now I know that a is greater than 1. So x is greater than 10. So domain is x must be equal or an element of 10 to plus infinity. 10 is excluded because 10 will give 0. Because we have log of 10 is 1. Log of 1 is 0. Log of 0 does not exist. So this is the solution. So you need to substitute with two variables and then follow this and you have it. So these were exercises with logarithms. With LM, it's the same principle. I hope you enjoyed the video. Please drop a like and subscribe to the channel.